So now you get to see how to figure out probabilities or proportions. Remember, those two terms are used interchangeably. So to find probabilities or proportions with the unit normal table. So these examples are going to show you how you go from x to a probability. So we'll want to know what the probability of a specific range of scores is. We'll take the score at the starting point for that range of scores, calculate the z-score for that score using a given mean and standard deviation, then use that z-score to go to the unit normal table and figure out the probability of interest. So here's our first example. So an IQ test has a standardized mean of 100 and a standard deviation of 15. And according to the Wechsler IQ testing agency, normal intelligence is anyone within one standard deviation of the mean. So anyone from 100 minus 15, or 85, to 100 plus 15, or 115. What proportion of the population is of normal intelligence? All right, so the first thing that we need to do, so remember, we're given x values here. So we need to take these x values, convert them into a z-score, and then figure out the probability using the unit normal table. Now in this case, we have two specific x values that we are interested in. Now, like in this example, we only have one x value that we're interested in, everything that's greater than 133. In this one, we'll just find z for 133 and then look for the correct proportion. But here, we're looking at two different scores. So we need to find two z-scores, draw our picture, figure out what we're looking at in the table, which proportion, and then we will figure it out. All right, so first step, z-score for 85 is equal to, well, what's my formula? So z equals x minus mu over sigma. Or in other words, the score minus the mean for the population divided by the standard deviation for the population. So the first one, 85, so that's our x in this case. And our mean is 100. And our standard deviation is 15. Well, guess what? I already said, you can already see, we're looking for one standard deviation above and below. But I'm going to do the calculations anyway, just to show you the process. So yeah, 85 minus 100 is negative 15, divided by 15, negative 1 is our first z-score. Now, we need to confirm our z-score for an IQ of 115. So now our x is 115, our mean is still 100, and our standard deviation is still 15. 115 minus 100 is 15 divided by 15. 1 is the other z-score of interest. So now I'm going to plot these in a normal distribution. And the way that I usually do this, so I'll label this frequencies, and then this down here is going to be my IQ test scores. And right in the middle, I always plot my mean, and I'm going to plot both x and z values. So my mean is 100. And I automatically know that the z-score for my mean is 0. That's always the case. All right. And then I usually also start by plotting out one standard deviation above and one standard deviation below the mean, because that tells you how wide your curve should be. So your points of inflection, when the curve starts to kind of jut out or go down, have more of a slope, should be at one standard deviation above and below the mean. So this one's pretty straightforward because we already found that one standard deviation above the mean is 115. One standard deviation below the mean, or a z-score of -1, is 85. So I'm going to draw my normal curve. I'm not a very good artist, but there we go. Good enough for me. And I'm going to separate the top 50% from the bottom 50% at the mean here. So it's good to practice drawing these things out, especially when you're using the unit normal table, because you need to visualize if you're looking at a body, a tail, or a mean to z. Well, there are several different ways that we can do this. First, I'll show you how to probably do it the easiest way, which would be to look mean to z. So we'll want to look for, in column D, right, mean to z here, and then also here, and then we're going to add those two together. Because the first one that we're going to find, if we find the mean to z for this, we're not going to necessarily know what this is, so we need to add it to that. Well, in this case, it's going to be the exact same two values because the z-score is 1 and -1. Remember, there's no negative values in the table, so we're going to be going to the same place for both of these. And this should be a review from the last lecture. So let's go ahead and use the unit normal table to figure out the proportion between mean and z, column D, for a z-score of 1. So we're looking in column D. We need to find a z-score of 1. We're starting with z at this case. Okay, z-score of 1, proportion between the mean and z is 0.3413. So this will be, this will be 0.3413 here. This is also 0.3413 for this shaded section. So you take 0.3413 plus 0.3413 and use our trusty calculator. 0.3413 plus 0.3413, and you get 0.6826. 0.6826. And that would be your final answer. So what proportion of the population is of normal intelligence? 0.6826. If this was restated as what percentage of the population is of normal intelligence, you would say 68.26%. Now, there's another way that you could find this. It's all about, visualizing what you're looking for and using the appropriate columns in the table. This is by far the easiest strategy for this particular example, but let me show you a different strategy that you could have used and you'll arrive at the same exact conclusion. So let's go ahead and get rid of all this goodness here. And we're going to start over at the point where we found our z-scores, and now we need to consult the unit normal table to figure out probabilities. Or proportions is how this one's worded. All right, means in the middle. Well, you could technically figure out, okay, so we want to find this middle piece here. Well, you could technically figure out the proportion in the body, so all of this for a z-score of 1, and then subtract the proportion in the tail for a z-score of 1. See how we're isolating this middle piece, what we're looking for right here. So we find proportion in the body for a z-score of 1. So let's find it. 1, body, 0.8413. So 0.8413, 0.8413. And then remember, we're going to subtract the proportion in the tail here for a z-score of 1. So z-score of 1, proportion in the tail, 0.1587. 0.1587. And let's confirm with our calculator. 0.8413 minus 0.1587 gives you 0.6826 yet again. Now, thinking about it this way, you could also say, all right, I want to find the proportion in this body minus the proportion in this tail to isolate the section of interest, and you would have the same exact math here. So I just wanted to show you every which way you could find it so that you understand that as long as you're able to visualize it and look in the right columns, you'll be fine. All right, let's move on to the next example. So we're still working with the IQ test distribution. Only now we want to figure out what proportion of test takers would be considered a genius and would make it into the Mensa Club for Geniuses. So we have our x value right here. It's going to be 133. So we are going from x to z to p. So we're going to find the z-score for an x value of 133. Then we're going to use that z-score to find column A, where is that z-score, go over and then find the correct proportion based on what we shaded in and what we're looking at. So the first thing I want to do is calculate my z-score. So z is equal to the score minus the mean divided by the standard deviation. In this case, 133 is the score, mean is 100, standard deviation is 15. So 133 minus 100 is, 33 divided by 15. And I'm not about to do that in my head, so 33 divided by 15 is 2.2. All right. That is our z-score. Now I'm looking at this z-score, and I'm well aware that I screw up with negatives all the time when I'm doing math, so I'm going to confirm that this makes sense. So my z-score is 2.2. That's a positive z-score. The x value of interest is above the mean. I'm feeling pretty good about my math. Also, I know that my score is supposed to be, if it's a z-score of 2.2, that's telling me that my x value is 2.2 15s, right? 2.2 standard deviations above 100. And that also makes sense. Like roughly in my head, if it was 2 15s above 100, it would be 130. So, 0.2 is about 3 points if you're thinking about 0.2 of 15. So it's always good to go back and make sure that your answer logically makes sense based on what you know about z-scores and what that tells you about the position in the distribution. Okay, so now I'm going to go ahead and draw my distribution to visualize what I'm actually looking for. Because you have to decide, am I looking in column B, C, or D once I find my z-score. So frequencies along the y-axis, we're still looking at IQ scores here. Plot my x and my z values. Again, I'm going to start with my mean right in the middle, 100. And I'm going to go ahead and plot my one standard deviation above and below. So we'd have 115 and 85. And I'm going to draw my nice, happy, beautiful, normal curve. Kind of beautiful. Here we go. Mean in the middle. And then remember, one standard deviation above is a z-score of 1. The mean is always 0. One standard deviation below is always a z-score of negative 1. And I'm going to plot my x is 133. It'd be like right here-ish. And we know that corresponds to a z-score of 2.2. Now I want to find out what proportion of test takers would make it into the club because they have an IQ score greater than 133. So that means I'm looking for these select few geniuses. And this is pretty clearly a tail. Now, even if you were looking for the proportion of scores greater than 101, 101 would be right here, and you'd shade this in, that would still be a tail because it's technically the smaller portion of the graph, although it's not much smaller than the rest of it. It's still a tail. But this one, it's pretty clear that we're looking at a tail. So let's go ahead and look at the unit normal table. We're going to find a z-score of 2.2, and then look for the proportion in the tail. So keep on scrolling down. Luckily, these are numeric order, so that makes it a little easier. 2.2. Not to be confused with 2.02. Be careful. 2.2. Proportion in the tail. 2.2. 0.0139. 0.0139. Now for this one, that's it. We found it, we're done, moving on. So the proportion of test takers that make it into the Mensa Club for Geniuses would be 0.0139, or if it was in terms of percentage, you could say 1.39%. So it is a very select group, not a whole lot of geniuses out there. Okay. Now let's move on to the sad end of this distribution. So we started off, optimistic. We're looking at geniuses. Now let's go ahead and look at people who are morons. And that is the technical term, or at least it used to be. I think they're a little more PC about it now. But anyway, we are starting off with, this time, two x values. So we need to find two z-scores based on x to then go to the unit normal table and find this proportion or probability. Okay, so our first z for an x of 41. So x minus mu over sigma, score minus the mean over the standard deviation, equals 41 minus 100 divided by 15. And 41 minus 100, I do not trust my brain. I trust my calculator. All right, negative 59. So negative 59 divided by 15. All right, let's see. Negative 59 divided by 15. Negative 3.933. Negative 3.933. That is our z-score. It's always good to label your answers and then draw like a circle or a square or something around it so that you can locate things. But don't fool yourself, you're not done yet. You still need to go to the table and find the proportions. So you draw out your normal curve. It's going to be a curvy semester. All right, here we go. IQ. The middle is still 100. I'm going to plot my one standard deviation above, my one standard deviation below. And then let's see. So where would 41 be here? 41 is like way on the low end. And then 55 is just slightly above it. And 41 has a z-score of, I'm just going to kind of draw it out here because I don't have room, negative 3.933. We still don't know what the z-score is for 55, so let's go ahead and figure that out. I'll just figure it out down here. So z for x equals 55. So we have 55 minus 100 divided by the standard deviation of 15. And 55 minus 100 is 45. I was able to do that one in my head. And 45 divided by 15 is 3. So the z-score for an x value of 55 is 3. I should have had the foresight to draw out my graph better, but I'm working with what I got. All right, so I'm going to draw out my distribution. All right. And I need to find the space between these two values. This is the trickiest type of example because it's not a clear mean to z situation, and it's also not just a single x value looking in the tail or the body. So I need to isolate that portion of the graph. Now there are multiple ways that you could do this. You could find the proportion in this tail and then subtract it from this tail, and you're left with what's left in the middle. Let's go ahead and do that strategy first. So let's first find the proportion in the tail for a z-score of 3 and then subtract the proportion in the tail for a z-score of 3.933. And let's add that negative there. But remember, there's no negatives in the table. All right, so we're going to find 3 in the unit normal table, look for the proportion in the tail. So z-scores 3, proportion in the tail 0.0013. So 0.0013, that's the proportion of scores in the tail to the left of a z-score of negative 3. Now we need to figure out the proportion in the tail for a z-score of 3.933. But check it out. This only goes to the hundredths place. So we're going to look for 3.93. And look, we don't have 3.93, right? So we're just going to go to the closest one, which is 3.9. Remember, this is an approximation. And we get 0.00005. All right. So 0.00005. So let's go ahead and plug that in, make it blue. 0.00005. And now let's get our trusty calculator out. 0.0013 minus 0.4 zeros, 5. 0.00125. 0.00125 is our final value. Whereas this represents all of these scores, and the blue represents just this proportion right here. So now we can use the body approach, whereas before we used the tail approach. So let's go ahead and color code, my favorite thing in the world. We can find the proportion in the body for a z-score of negative 3.93, and then subtract that from the proportion in the body for a z-score of negative 3. And we will end up with the same exact value, but let me confirm that for you. So, and now I've got to change my color coding here. So now this guy is red, and this guy is blue. All right, don't want to be confusing. There we go. Okay, so let's go ahead and go to our table. And we're already at 3.9 here. And I know this is the proportion in the body. 3.9, portion in the body, 0.99995. Now notice something. If you add the proportion in the body to the proportion in the tail, you get 1 because that includes the entire graph. All right, so 0.99995. .99995, and then we need to subtract the proportion in the body for a z-score of negative 3. So let's find 3, proportion in the body, 0.9987. 0.9987. So 0.99995 minus 0.9987. Haha! Same exact answer we got before, 0.00125. So 0.00125 is the proportion of scores between 41 and 55, or the probability of randomly selecting someone with an IQ between 41 and 55. Now, you could also use the mean to z column to figure this out. Again, I'm showing you every single possibility just to really help you understand how to use that unit normal table. So let's do a little bit of erasing again. Okay, here we go. Goodbye, pretty arts. Okay, so we could, let's draw our curve again. Okay, we could technically find the proportion from mean to z of 3.933, so all of this, and then subtract the proportion from mean to z of 3. So let's go ahead and do that. So what is the proportion from mean to z for 3.933? All right. 0.49995. 0.49995. 0.49995. All right. And then subtract the proportion between the mean and z for a score of 3. All right, 3, mean to z, 0.4987. 0.4987. And then let's just confirm that we get the exact same answer that we have the other two ways of doing this. 0.4995. Oop, I missed a 9. 95 minus 0.4987. Aha, there it is again, 0.00125. So you don't have to do it every which way, but I just wanted to show you every single possibility. You get the same exact answer. It just depends on how you're comfortable shading in your graph and what makes sense to you. So now let's shift focus to, we start off with a probability or a proportion. We use the unit normal table to then find the z-score. Then we use the z-score to calculate x using this formula here. So we're still using the same distribution, the IQ distribution. But now we want to know what score is at the 90th percentile. So we have a situation again where we have p. So if you see percentile, that is akin to, probability or proportion. We're going to use the unit normal table to locate z, and then we're going to calculate x. Now, if percentiles bother you, if they still don't make sense after looking at percentiles and frequency distribution tables, maybe a picture will be useful. So, you know me and my distributions. I'm drawing it out. All right. And we'll just make this a very generic distribution. So, x and f. Normal curve. Actually, I'm going to label these as percentiles. So if you think about percentiles, the 50th percentile is in the middle. 50% of scores are equal to or less than the mean. And then as you go to the right of the distribution, the numbers increase. So we've got 50, 60, 70, 80, 90, 100. And then to the left, they decrease. So for example, 40, 30, 20, 10, and 0. So somebody at the 90th percentile has a score that's as good or better than 90% of the distribution. Or in other words, only 10% of test takers did better than someone at the 90th percentile. So we're looking for the score that is right here. And so we could consult p equals 0.10 in the tail, top 10%, right? Or p equals 0.90 in the body. And remember, I showed you that body plus tail equals 1. So guess what? The same exact z-score is going to be located using either one of these strategies. If we look for 0.10 in the tail or 0.90 in the body, we're going to get the same exact z-score. Let me show you. So whereas before we were starting off looking at z, now remember we're going from probability to z. So we're going to start off looking at one of these. So remember, we can either look for 0.90 in the body or 0.10 in the tail. So I am going to cruise through here. These are also in numeric order. So, okay, these are getting bigger. We don't want that. Here we go. Keep going. Look for 0.90-ish in the tail. Or, sorry, in the body. Body. All right. So what I usually do is I look for the value, because remember, not all values are here. So these are tails. These are bodies. I'm looking for 0.90 in the body. I look for the value just below the value I'm looking for. So this is just below 0.90. This is just above 0.90 in the body. And then I figure out which value is technically closer to 0.90. So this one is 0.0007 points, or sorry, 3 points, so 0.0003 points away from 0.90. This one is 0.0015 points away from 0.90. So this one is technically closer. So I'm going to go with a z-score of 1.28 to find x. Same thing with the tail. If we were using the tail, we would be looking for the closest number to 0.10 in the tail. Remember, this is the proportion in the tail. So this one is 0.003 away from 0.10. This one is 0.0015 away from 0.10. So both cases, we are being directed to look at a z-score of 1.28. So if we're thinking about z-scores now, 1.28 is the z-score that's located right here at the 90th percentile. So now I'm going to use, I used my p-value, my 0.90 or my 0.10, depending on if you want to look in the tail or body, to find the z in the unit normal table. Now I'm going to use z to calculate x using this formula right here, which can be derived from the z formula, but I'm just going to go ahead and jump straight to the simple way to find x using z, standard deviation, and the mean, which is this formula. So we just plug in our values. We just found z of 1.28, so 1.28 times 15 plus 100. So 19.2 plus 100 is 119.2. That is the score. Score means x value at the 90th percentile. So if you drew this and we had x's, 119.2 would be in that location on the distribution. So if you scored 119.2 on the IQ test, you did as well or better than 90% of test takers, and only 10% of test takers did better than you. Or you could say you're in the top 10% of test takers. All those things mean the same exact concept. So now let's make this a little bit more challenging. Now we're looking for the two scores that define the middle 90% of the distribution. So let's draw this out. Again, we're going to go from P to Z to X. And in this case, we're going to have two X's because we're looking for two scores that define the middle 90% of the distribution. So let's go ahead and sketch this guy out. So frequencies, IQ scores. Again, the mean in the middle, 100, one standard deviation above, one standard deviation below, and my z-scores. And let's draw this guy out. There we go. So the middle 90% would be like all of this. The middle 90%. So the middle 90% of the distribution, or the middle P equals 0.90, right? You can just take percent and divide it by 100 to get the probability. This leaves P equals 0.10, or 10% of the distribution left. But that 10% needs to be divided into two tails. So you can divide this by 2, and you get 0.05 in each tail. There you go. You could also think about this as splitting each side into half. So 0.90 divided by 2 equals 0.45. So you have P equals 0.45 from this value to the mean, and then P equals 0.45 on this side from this score to the mean. Either way you think about it, it's going to work out. You just have to figure out what the z-score is based on this. So let's take a look. Let's go ahead and look for, and I'll write the columns. So this is all about column D, the mean to z. These down here are all about column C, the proportion in the tail. So let's go ahead and look at the unit normal table and find 0.05 in the tail and 0.45 from the mean to z. So tail, 0.05. Keeps getting smaller. We got to keep going. Oh, we went too far. Okay, here we go. Oh no! Check it out. There's two scores, because we're looking for 0.05 in the tail, two scores that are exactly 0.0005 points away from 0.05. If that is the case, if there's not one probability or proportion that's closer, you go with the higher z-score. So it's a toss-up between these two because they're both the same distance from 0.05. So in other words, it's a toss-up between z-score of 1.64 and 1.65. Go with the higher z-score, 1.65. Now, if you were using between the mean and z for this, It would also lead you to the same exact place, because remember we said the middle 90%, split that in half, that's the middle 45%, or the middle p equals 0.45. 0.45 is right between these two values. Still go with the larger z-score, so 1.65. Now because these are both equal distance from the mean, then you're going to have negative 1.65 and positive 1.65 on either end. 0.05 in the tail on this end, 0.05 in the tail on this end. Or 0.45 between this and the mean, and 0.45 between this and the mean. So you're getting the same exact absolute value for z, it's just on the left side it's negative, on the right side it's positive. So now we have our z-scores. We know that for one of these scores we have z equals negative 1.65. And for the other, we have x for a z-score of positive 1.65. So, using our awesome x equals z times standard deviation plus the mean formula, we have negative 1.65 times 15 plus 100. And I've already done the math in advance. So negative 1.65 times 15 is negative 24.75 plus 100. This is just like saying 100 minus 24.75, and you get 75.25. Now let's go to, so this is our low end, 75.25. Let's find our high end that separates the middle 90% of the distribution. So positive 1.65 times 15 plus 100. So this gives us 24.75, but positive plus 100 equals 124.75. That is our high end. All right, so now let's do our last example. What score is at the 15th percentile? So remember the picture I drew about percentiles. You know, the lower percentiles are to the left, the higher percentiles are to the right. And the 15th percentile is basically saying what score separates the bottom 15% from the top 85%. So if we drew this out, I'll do it real quick here. And 0 in the middle, plus 1, standard deviation minus 1. The bottom 15%, the 15th percentile, would be like here-ish. So here we would have p equals 0.15 in the tail. There's our mean. Or we could figure out the z-score that corresponds to p equals 1 minus 0.15, 0.85 in the body. We're going to land in the same exact location on that distribution chart on the unit normal table. All right, so let's go ahead and figure it out. And again, this is another example where we go from p to z to x. So 0.15 in the tail, 0.85 in the body. Okay, tail. I need to go back so it gets bigger. 0.15. Okay, so here we've got one that's just above and just below 0.15 in the tail. Also, we have a score that's just below 0.85 in the body and just above 0.85 in the body. We're landing in the same exact spot. And in both cases, 0.1492 is closer to 0.15 than 0.1515. So this is 0.0008 away from 0.15. This is 0.0015 away from 0.15. So this one's closer to the value we actually care about. Same thing here. This value is closer to 0.85 than this value. So we land on a z-score of 1.04, and that's what we need to use to figure out what x is. So this is going to be negative 1.04. Be careful, right? That's why you need to draw it out. It's to the left of the mean, bottom 15%. So x equals z times standard deviation plus the mean. So we have negative 1.04 times 15 plus 100. Negative 1.04 times 15 is negative 15.6 plus 100. And the x value of interest is 84.4. That is our score. And looking at this makes sense, right? We're looking for the bottom 15%. So we're looking for values that are lower than the mean. Well, the mean is 100. This is lower than the mean. And by sketching this out, we can see that one standard deviation below the mean is 85. So 1.04 standard deviations below the mean should be pretty close to 85, and this in fact is. Now, if you didn't draw this out and you said, oh, 15th percentile, 0.15 in the tail, and plugged it in and looked in the table, you might forget that you're looking for a negative value, and you may have come up with something that was larger than the mean, and that would be incorrect. So I want to see graphs on all of your quizzes. I think that that is the best strategy for preventing mistakes and keeping things straight. I've been doing this for years, and I still draw pictures to figure this stuff out. So I know that I explained things pretty thoroughly in this video and kind of showed you multiple ways to do things, but it's really important for you to understand how to use the unit normal table and to make it work for you. Use it in the way that makes the most sense to you.